All right, suppose we'll go ahead and get started. This week you'll obviously be putting together a telescope assembly. The assembly, the parts I give you are somewhat inconsequential because the real lesson this week is how to best execute drawings given parts of assembly. So you're going to put this. So if you put this together and make a drawing of it, we'll also be studying a little bit of assembly configurations, how to detect interference in assemblies, and some other simple items. The first thing we need to go over today is something interesting you can do with assemblies. This is pretty typical, as you'd expect. I've already assembled this. I give you all the pieces. I don't give you the assembly file. It'll take you like 10 minutes to put it together. It's not a big deal. You should have the appropriate degrees of freedom. You know, the base should be able to rotate. This thing should be able to pitch up and down. The missing components that you would finish this off with to make it a real part, you put a, obviously it's meant to be gear driven so you can control pitch, like a microcontroller or something. So you can put a camera on the back and follow some sort of star or galaxy and get a really good photograph of it. Is that a wasp in here?
Yeah.
That's nice. Let's see who gets unlucky.
Great.
Anyway, so that's what we're working on this week. This telescope, if you care at all, is actually one that I own. So I was making this part a few years ago. I was like, well, that'll make a good enough lesson part for people. So designing a mount for a real-world telescope. It's an 8-inch Schmidt-Cassegrain telescope. It's a reflector, and it's a nice little bit of kit. Anyway, so one thing you can do with assemblies that I didn't mention previous, or even in previous years, is I want you to try to figure out the difference between what this is, notice I can still move it, and this guy. What differences do you see? I mean, yeah.
Did you make the part from the assembly?
Did I make a what?
The part from the assembly?
Yeah, that's what happened. You notice that these are dumb solids. These have no components in them. They're not, I mean, you probably saw that the name, actually no, I didn't, but yeah, it's a part from the assembly. You can save assemblies directly as a solid part, but you lose the ability to control the motion. They're fixed. You can't go here and change them. It kind of dumbs everything down, but it's a good way. Say there's something really complicated you've been working on, a whole formula car, and you want to send it to somebody to do some neat renderings of it. Or you want to send it to, I don't know, some other school or somebody else, and not give them full access to all your parts to be able to change them. You can send it like this. Yeah.
So when you change it to a solid or to a solid part, can you change it back to an assembly or whatever? Because I did that by accident on one of the holes before, so I had to redo it.
I don't believe you can go backwards. It doesn't save all the mating information with it. It doesn't save all the parts. In fact, by definition, it just saves. These are, I think, it uses IGES files. It just includes them and puts those together, so you can't even rotate it. It's just a bunch of fixed stuff. You can glance at it as a whole, but basically becomes one big part. It kind of simplifies everything. So the smaller file size, that can be helpful sometimes. These files can be kind of cumbersome for computers to deal with on occasion. So anyway, to do this, it's quite simple. As you'd expect, just go to File, Save As. Whenever you get this question, it's basically saying, do you want to check and make sure all the relations are good before you save it? And usually the answer is yes. Saves new name, saves a copy. I usually do save as a copy. The descriptions of what the differences are right there in the menus. Instead of selecting a solid asm.sldasm, go straight to this and choose part.sldprt. It's the same exact format as all the parts we've been making throughout the year, and so we'll save it as a solid like that. So that's how you do it. That's how you create these kind of dumb assembly files. They can be quite useful if you need to share some information without sharing everything. This can be like if you like a certain configuration of your assembly, you want to take steps towards making a 3D print of it, do it this way. You can put it into a part, and just add the base or whatever reinforcing material you need to add. Maybe you had a connecting strut on your formula car that if you just 3D printed it in plastic would just snap and break. It wouldn't even hold its own weight. So maybe you need to beef that up a little bit. It's easier to do it as a part. You can do it this way. Anyway, so that's how you do that. We're done with the part version. Is this part of this? Yeah, it's part. Just know that can be done. One thing that's very useful in assemblies is you can create alternate configurations. We did that a little bit whenever we discussed design tables and parts. But even more common than doing a design table is alternate configurations and assemblies. So you, again, are in Configuration Manager. And all you have to do is right-click up here, you say Add Configuration. It asks you for a name. I've conveniently also given you one of the telescopes with a Canon 7D. It's a DSLR camera. Oop, if I can spell. I'll just name this configuration that. So you see we have one configuration called Canon 7D camera and one called default. We have the Canon 7D activated right now. So any changes I make in this tree, if I hide or show items, if I suppress or unsuppress items, that'll be saved in the config. So what I can do is just go over here and unsuppress this 7D, which we've already mounted. You see I have both. There's two parts actually existing simultaneously in the same space. You have the Canon mounted camera and you have the telescope with just the optical viewing port. So I'll suppress the optical viewing one. So now this configuration, which is labeled Canon 7D, shows a box with space reserved for that camera. I didn't want to model the whole, every detail, every curve of the body of the camera, so I just made a cube that represents the entire volume of it. So in Config Manager, now if you switch back and forth, you're also switching back and forth between views. You have one that shows the camera, you have one that shows the direct viewing application, so it's quite handy. So you can see how that really helped you. Say you had a different configurations for your Formula car, different configurations of your AC-72 yacht you want to go out and beat the Kiwis with. You can switch between them this way and see what's actually different about them. So it's kind of handy. If we have, let me activate the camera one real quick. We have this guy open. I want to make sure that as this telescope is pitching up, like say I'm tracking some objects go straight up in the sky, I want to make sure that camera is not going to hit the base plate and just get cracked off by the motors and break lots of expensive things and cause me to have a bad day. So right now, is that camera going to hit the base? Who thinks so? Okay, well, who thinks it's going to miss? Who really doesn't care? All right, so anyway, we can move the component, turn on collision detection. Remember, this is where we also did physical dynamics. You have the option to tell it to stop at collision. Also wanted to make to beep at us. Where's that option? Sound, yep, it's already checked, okay. So anyway, all you have to do in this case is just grab the part, and then you see it in fact does hit. It highlights the surfaces and the faces that are interfering with one another, so you can check your kinematics for conflicts. You can check your parts, your mechanisms you design in assembly manager to see if they're going to interfere with one another. So that's a good way to check things out. What do we do if we want to fix that? I mean, obviously we can't have that be a problem like that. What's the easiest, quickest way to go about fixing the problem? Yeah, go ahead.
Take off the camera.
Well, okay, take out the camera. Then you can't take a picture of it. What?
Make the two triangular legs solid.
Yeah, so this is actually a very simple thing to do. All you have to do is right click on those legs, say open part. So if you're dealing in assembly, we have the part right there, and you can see that it's all it is one boss extrude. You can view the sketch, edit it. I've got this set up, so all you have to do is go in there, say, 14 wasn't enough, let's try 20. Everything changes. See, that's why you want to go about setting up sketches appropriately. So if you change one main dimension, everything else kind of stays where it should be. The relationships between dimensions are set up appropriately, so you capture design intent. You could dimension this differently. There are tons of different ways to dimension all sorts of sketches. But if you did not capture your design intent through the way you dimension the sketch, you change that dimension and things just go crazy. I'm sure you guys have seen that a little bit as you're working. You like try to drag one line and the rest of the lines just go off into space. So yeah, that's the way to take care of that. Let's go back here. It tells us models contained the assembly has changed. Do you want to update it? Yep. So now it's much taller, and obviously it's not going to be a problem. Spin that thing around all we want. For the sake of making the drawing, I'm just going to undo those changes. We're going to leave it interfering for the moment. Okay. Switch back, let it re-update, and re-evaluate. That's what it means by rebuild. You notice when I switch back, those arms are no longer on the base plate. Whenever it went and rebuilt all the constraints, they realized I had to move everything back. So that's what's going on there.
I have a question.
Yeah.
Could you put the camera on top of the ocular viewing thing?
Oh, they can't put the camera out here?
No, like the other configuration
Ah.
where it's got the L,
Yeah.
and then put the camera on top of that.
Could you?
Yeah.
I mean, you certainly could. I mean, some people definitely do that. Just as an aside for optics, the reason why they oftentimes get the straight shot right into the mirror, because right now, in fact, the mirror is even modeled. Let me pull up the PDF you guys have to make. Okay, in fact, right here, the right side. So the main bit of light comes in. This is the main reflecting mirror here. It's parabolic, or roughly. And then you have one more mirror up here in the front, this little disc. So the light comes in, bounces off the back, hits the disc, and then comes right into the camera. The reason why astronomers mount the camera directly back here, so going through another bend, is inside that 90-degree bend is a mirror, another mirror, so 3 mirrors. Every time you bounce light off something, that mirror will absorb a fraction of light, and it messes up the pathing. So that's why telescope guys are so persistent about the shape of their mirrors, because if even a little tiny bit of roughness really messes up the image. So the fewer bounces you go through, the better off you are. The fewer lenses you pass through, the better off you are. So that's why the straightest shot is the best you can do. So that's why they do it optically, but yeah, you certainly could to save some space. Okay. So this is I went ahead and pulled it up. This is the drawing you have to recreate this week. So once you assemble a telescope, this is pretty straightforward. This is what you did last week with a part. It's just rehashing the same things you've learned to do with an assembly. It's not anything different. May as well go ahead and create that right quick. I'll just go to File and make drawing from assembly. It's telling me that I already had that made. But, I think A-size paper. It's like, are you sure you've already done this? Maybe something different. Go to View Layout. Use Standard 3 View, which occasionally does the right job. In this case, not at all. I'm just going to delete that. In fact, that's horizontalizing so far off. That's because I rotated it out of sync. Should close that. Go to model view, just browse for it. This is what I wanted to show you. Remember, the most helpful button I know of when making drawings. So whenever it asks you to make a drawing first, it just gives you the box. Always remember to check preview. It's going to save you a lot of time to see which view you're actually dealing with. So in the actual preview that we want, we need probably the front view. I have to go. The reason it's messed up is because in the actual SolidWorks file, the orientation is a little bit off. It's this. So rotate this back to be square. I could certainly orient this any way I like. I can update the drawing. See the changes propagated. So having this oriented properly is going to make your life a whole lot easier whenever you make the file. So let's take a look at what we need to finish here. Orientation is just highly wrong. Show this side. Just warning me that the dependent views will change as well, and I'm fine with that. So you see, what is it called whenever the other views move with this one? What is it in SolidWorks that keeps those? Is it the parent view? That it deals with that, yeah. The one that I'm moving right here is the parent of the subsidiaries. But what is it called that we need to break if we want to move them around independently? Alignment, yes. The isometric view is obviously not, it doesn't care about alignment. In the drawing, we have the isometric twice the scale of the others. So what do I do to change the scale of the isometric?
Click on the object, right click on it.
Or you could right click. Easier way to change scale, just click on the view, go down here and use a custom. So do 1 to 8, do whatever I like to match scale. How do I change, I believe in the view, in the drawing, which is extraordinarily tiny. This is showing hidden lines in that subsidiary view. How do I get it just in that view to be hidden lines?
Right click on it, show,
Right click on it. Do what?
go to show.
Go to, yeah, display
Just
styles.
push blue box on the side screen.
Do that, or you just click here, you click that. Which honestly, using the menu here over to the left is, you've got a lot of options there, it's probably a quick way to do things. Right now, I still have that poorly aligned, I would probably try to do a better job lining that up before starting drawing. I was just going through this, how do I create another sheet? Because this one, we'll just say that's good enough, I'll add the dimensions, you guys get the general idea, don't waste your time. How do I add another sheet to this?
Download.
So this is a lot of review this week, because it's just exactly the same as parts. All right, so let's look at the second page. What do we have to do on this? Who knows how to make that view?
Oh,
Exploded view.
Exploded view, so you get to the back. You said you do know how to make it? You're very
I know
confident.
how to make it in Inventor, but not SolidWorks.
It's actually quite easy. There's no need to go back and actually go through the entire, making another, what would I call it? Making another assembly.
Or
Because you
just
can
use
create an
Bind up there.
exploded state. You just click on the exploded view button, and it brings up this dialog box, which basically allows you just to grab the parts that you've assembled and move them in a single direction. So we'll just start, like what would be a good part to kind of keep centered? Think about, when you ever do the
The
what?
base.
The base, right, okay. So, let's keep this base, the rotating one, fixed, and we'll take this one and move it down a little bit. So you simply click on it, move green down. Then you can click these sides, click on the red arrow, pull it out. You can do a controlled distance, but this is just stupid easy to do. Drag it out. Oh, come on, Hayes. There we go. I mean, this is, it's not a problem, make it pretty easy to do, even for really complicated models. You can drag this and push it straight out. In fact, is it tilted a little bit? I probably shouldn't tilt it. There we go. So you'll see that I'm actually only getting cardinal directions when I click on this, but if the telescope was pitched up, which this one is slightly, I should have pitched it up more to be more descriptive of what's going on before I did exploded view. But notice when I slide this forward, it's actually starting to interfere with the part itself. It's not actually going down the axis. So let me delete explode step 7, so that goes back to where it was. If I want to move that directly down the axis of the telescope so it slides off like it would in real life, right-click on this hub. This is a good note to take because I get a lot of questions on this every year. Right-click on that hub, say move to selection, and select that back face. So now that blue vector is perfectly aligned with the telescope, and there you go. So now it's no longer going to interfere with it. So you see the difference between the one that I drug off straight in the X direction and the one that I dragged off axially around the telescope. So that's all you have to do to create an exploded view. One thing that's kind of nice is if you go to Configuration Manager, you open up that tab, Exploded View 2, you can animate the flash, which will basically undo everything. You can save this as a file, as a little video if you wanted to. And probably the more interesting thing is you can animate the explode. So it shows your device coming apart, or you can show it being put together. So that's something really easy to do, something that really kind of wows people in presentations that takes about 4 seconds to make. Keep that in mind. So anyway, adding the exploded view to a drawing is the next step. So we'll create sheet 2. One other interesting thing about sheet 2 is where did the format go? All that big block of information down here, it's gone. A lot of times I like to keep drawings clean, especially if they're an informational view like an exploded view is. It's not necessarily a dimension drawing. So you just grab sheet format 2, delete it. It's gone. Annotation, put in a model view of the simple telescope. Notice you have options here. You have the configuration you want to use. We have the default showing the direct viewing for optics. You have the camera configuration. Underneath that camera, you have the option to either show it or not show it in an exploded state. In this case, we definitely want to show it exploded, so there we go. Change that scale a little bit. I can make it go solid if I wanted, but I'll keep it that. 12, I'll go bigger, 8. Yeah, that looks great. How do I rotate this view? So I need to make it look like this, but it's facing the wrong way.
Towards the top of the screen. There you go.
When you click on that, you can finally spin it around.
Whenever I tried to do that on my homework, I was never able to.
Click the green checkbox.
Right.
The thing that happened there. Remember how I made this isometric view as a child of this drawing? If I try to do the same thing up here, I get your problem. Notice it won't let me click the green checkbox. You can only shift independent drawing views, because if you do it in the traditional 3-view drawing, you get a front, top, right. And the isometric view, I believe each line, like perspective lines, there's no perspective in isometric, usually enough, but the lines are angled at 30 degrees, something like that. There's a standard it's trying to follow. That's why it doesn't let you mess it up. It's trying to protect yourself from yourself. So, if you do want to maneuver things, just simply go to insert an independent model view, isometric, and then notice that one's still exploded because I didn't check the right box, but you can manipulate that all you want. So that's what's going on. And please, if you guys have problems like that, as I'm going through this lecture, just raise your hand and ask a question. I'm more than happy to answer. All right, so we have the exploded view in, but now we have all this other junk we need to add into it. These drawings are actually very, very useful. You'll do them a lot for parts that have to be assembled for people. This up here on the top left is a table called the bill of materials. They're a huge pain to have to keep accurate. If you have to do this manually, like how many screws do you need, how many bolts, how many pieces of wood go into your design, how many square feet of this or that.
How many Legos in the box?
How many what?
Legos in the box.
Exactly. Yeah. You can have a bill of material built for a Lego set. It's a perfect example. They're huge, huge pain to actually do by hand, but thankfully SOLIDWORKS kind of does it all for us. It knows how many of each part are already in the assembly, so why wouldn't it just make it? So insert, tables, bill of materials. Select a drawing view to specify the model for creating. Which view do you want me to create the bill of materials for? Exploded view makes a lot of sense. Standard bill of materials template, top level only. Usually all these options are just fine, though you can change like the weighting of lines, everything else if you want. I'm not too worried about it. We'll just say, all right, and then click right there. It's done. It automatically references the assembly and tells you how many of each object you're going to need. If you change the assembly, if you change that view, it updates the bill of materials. And the kind of the coup de grace here, the ultimate awesomeness is that you can go, well, the awesomeness drawing SOLIDWORKS gets. Go to annotation, auto balloon, click on the drawing you want, and it automatically it references the bill of materials. It tells you which part belongs to which line. So you can very, very quickly idiot-proof the assembly of your design. It's a very common task that engineers do all the time, so they have pretty much automated the entire thing for you. I guarantee you that knowing how to auto balloon stuff will save you 5 minutes on your final exam. So know how to auto balloon, know how to manipulate these things. Because if you're stuck by doing this by hand, it's going to be a lot. You have to make sure the numbers correspond and everything else. So you have different balloon alignments. You can have them all go above, below, to the left, to the right. I kind of like the surrounding. Just say okay, and then you can finally manipulate these a little bit, kind of move them to reasonable places. Obviously, off the paper is not going to do you any good. I'm sorry. Thank you. It's a very nice courtesy laugh. Anyway, so there we go. Bill of materials. You can insert descriptions. Like if your part file has a description in it, like saying what it actually is and what it does, or how you put it in, that'll show up. You can change some other columns if you really get into drawings a lot in SOLIDWORKS. You can go in there and under bill of materials, like sometimes bill of materials will be pages long, just in and of itself. You don't have any pictures to go with it. It's just 18 pages of stuff you have to buy to go build this part. One thing that's really helpful, especially with aerospace design, is that you can create a column for weights. You can list not only the parts you need, how many of them you need, but how much each one of them weighs, how much a subassembly should weigh. So that's really good for keeping track of the total weight of an object. As you're making these parts, as you're telling somebody to go get things, are you on spec? So that's a good deal. So delete format, we've done that. Section cut, we'll make one less drawing down here. What you don't need to put in. So page 3, we're kind of back to the standard type stuff again. Section cuts, what is this called? This whole drawing is a cross-sectional cut, but specifically circle C. Detail view, yes. Obviously that circle C pops up on the right side with a different scale. One thing you will have to add in is the crosshair in the bore of the telescope up there. 2012 made that quite easy. Whenever I did this work yesterday in 2013, it flakes out for whatever reason. But I'll show you how to get around that, because sometimes you just have to brute force a drawing. Oh, open the wrong one. I was wondering why that was already done. All right, sheet 3. Let's put in a view layout, model view, telescope symbol. How do I get it back to not be exploded view?
Check the box.
Uncheck that box.
There we go. What you have an option to get defaults or Canon 7D, all the defaults. Why is it not changing? Restart the computer. You can go ahead and turn it off, turn it back on again. Alright, well, lo and behold. Word. Okay, so which view do I need? I need the top down view. Let's look for that. Okay, so that works just fine. The problem is it's rotated. Let's just assume for a second I have that lined up so the telescope is actually straight. Again, why is it not straight in my drawing? Because in the part, it's not, oh, that's not the part. I guess I have the part closed. In the part, it's not straight enough. You can go ahead and add a mating constraint to do that. It won't be an issue. Okay, to rotate this, you can simply click on it, right click, and you have the 3D rotate up here, or you have the 2-dimensional rotate. Click 2D, change the drawing view angle by 90 degrees. Apply it. Well, that's the wrong way. So negative 90, apply that. All right, good. So now we're pointing in the right direction. Do the section cut, we do as we always do, section view, horizontal, good enough. Good enough for teaching. Oh, actually, there we go. So now we have the section cut view of the telescope down there. The total sheet scale is off. The one thing I really want to get down to show you is the view E. Too many things over at once. Let's change the total sheet scale, or at least the scale of this first guy. So 124 will be 1 to 12. Everything is propagated downstream because this one's not only aligned with it, is a child of the original drawing. Okay, so if I wanted to create a view looking straight down the board of this telescope, keeping in mind that it's tilted up a little bit, how would you do it?
Auxiliary?
See, exactly. Auxiliary view. Like that. Go off to the side, now we're looking straight down the board of the telescope. Notice it's off center, it's still aligned with it, so we have to right click, break alignment. That's going to become somewhat a common task for you. Drag it up here, 2-dimensional rotate, to get that somewhat vertical-ish. Nothing can be simple, right? Nothing can be simple. Oh my gosh.
Oh, perfect thing, SolidWorks.
It keeps on snapping it. Don't snap.
I believe in you.
Change the angle from the box up there.
What? Yeah, I could just type it in. Negative 10 is what it needs. Oh, you're wrong.
Negative 5.
5. Oh, 4. Maybe 3. 4.5. All right, good enough. Good enough for lesson. Anyway, so now the problem becomes is how do you insert a center mark? Normally you go to annotation, center mark, mash on a circle, and it works. But it says center marks can only be created on arcs and circles. Why is that not an arc and a circle? It looks pretty circular to me.
Because we're not looking at it straightforward.
It's not perfect. In fact, this center mark tool in 2013 is extraordinarily particular about it being exactly a circle shape. So one thing that becomes kind of common practice, a workaround in sketch mode, is if you want to get a center mark in there, just draw a circle for the moment through sketch, and then you can go back, annotate a center mark as long as you select the actual circle, and it works. So if you need to dimension to a point that you can't click on, if you need to put a center mark on something that isn't round enough, just sketch in a temporary line over the other one that will be perfectly round for it. So that's how you can work around those things.
How did you make that not perfectly circular?
The telescope is perfectly circular. Like the part itself is a revolve. It's like a circular shell. The problem is like when you view a circular aperture at an angle, what does it become? Ellipse. So that's what's happened here. We're ever so slightly off axis. I think, this way. And it's extraordinarily particular, even a fraction of a degree less than, yeah.
Is there a way to like hide, like give a bunch of crosshairs on things like in the triangular part, it came up and had like all the little circles on it?
All of my crosshairs.
Crosshairs, and it's just kind of tedious to go through and do all individually.
What you probably have checked there is a setting that says automatically add crosshairs to all circular holes. You can turn that off. I think that should be underneath the crosshair tool. Otherwise, no, I think you just have to basically go and delete them all. So it's one of the automatic settings in drawing. Okay, so let's just cover, guys, conversation's getting kind of loud. All right, what you have to do for this week is recreate the telescope mount from the given parts. That's pretty simple. Use your telescope assembly to create the drawing as shown in that assembly PDF file. That's on OC to OK State. 3 pages, not a big deal. Create 2 telescope configurations. One for direct viewing, meaning the optical path to stick your eye up to. One for using the given Canon 7D mount. That's also a part given to you in that parts download zip file. Adjust the parts as necessary. Let the camera mount version pivot a full 360 degrees in pitch. Means I need you guys to go in and edit a part of your choice. You can bend the optical mount. You can extend the leg. You could, I don't know. I suppose you're going to use a DP camera. That's fine. But it says, doesn't it say? I see it says use 7D, right?
Yeah.
Yeah, the camera mount version. Anyway, save that assembly. Once you've modified the parts and length, save that assembly as a part. As a part. Don't turn in another assembly file. We want to see that you guys know what to click on to save as a part. And turn that in. So, 2 things you have to turn in. Recreate a PDF of the telescope drawing and a .SLD PRT file showing the telescope assembly. What's the difference between saving an assembly as a part and saving it as an actual assembly?
Part of it.
The what?
Part of the dump solid.
Part is a dumb solid, right? You save it as assembly, you have to also save all the parts with it. And you can still do all the kinematics, you can view all the relation, go ahead and change the parts. Just change the whole assembly. If you save it all as a part, then you just get what you get. It's kind of just a visual representation. Yes, ma'am?
Whenever you turn in the PDF of the drawing, will there be 3 separate ones for 3 different sheets or?
That is a good question. This time I want you to turn in a single PDF. I guess I should have said a single, but just a single file that has 3 pages. So the way you do that is in SOLIDWORKS, don't make a new drawing file for each sheet, just add them as new pages down here. And whenever I go to save as PDF, it'll save them as a PDF of 3 pages. Yeah.
The drawings, are those before or after we've modified it to allow us?
The drawings should correspond exactly to what you're given, so you can do it before or after, just make sure whatever part you make the drawing from is the original kind of short version. Okay. So the drawings are based completely off of the optical tube. In fact, something's kind of interesting since I've got this pulled up and you asked that question. Say you wanted to change this whole sheet to the camera version, click on the parent file of everything, change from default to Canon 7D camera, look what happens. Pretty handy. I mean, AutoCAD would have just taken them, what, half a day to make the change, so SOLIDWORKS is pretty good at this stuff. Yes?
How did you create the exploded view?
Exploded view, right. Where is the part? There we go. Okay. I created it by clicking on exploded view. There's a button up there in the assembly tab. If you want to go back to standard view, simply right click in white space. You should be able to click collapse. That puts it back to where it came from. Again, remember we can change this, change the different types of configurations. Both of them are exploded now. Right click, collapse. You should be able to right click and explode. Really? Check that out. Oh, well, you always right click on this. Show it there. So that's how you go between that. You can also notice you have explode line sketch. So you've all seen the part drawings, like putting together. I always use the lawnmower example because I've had to do a spare number of those in my life. Just the little dotted lines that show which bolts go into which holes, matching to which things. That's how you do that. It shows you the little dotted paths between the different holes. Any more questions? All right, I will see you guys in the lab.